attending today. And thank you if you're watching the recording later on. And I want to say happy Computer Science Education Week. Hopefully you guys are doing some things in your classroom or your school to celebrate computer science, to jump in, whether it's an hour of code activity, whether you already have a computer science education program and you're looking to push it to the next level. Keep an eye out on our LTC social media sites as we'll be promoting some different activities, some different resources throughout the week. But we're definitely glad to have you here with us today for our special Computer Science Education Week themed webinar. My name is Brian Bates. I'm the Director of Professional Learning with the LTC. I'm joined today by my co-host, Matt Jacobson, the Online Learning Coordinator. He'll be helping me out with moderating the chat a little bit and helping make sure everything runs smoothly in the background. Also joined by another wonderful LTC colleague, Sarah Phelps, who also doubles as a Code.org facilitator. And before we turn it over to Sarah to talk a little bit about implementing computer science in the K-8 realm, just a couple of reminders. We are going to record this webinar. You'll get the recording in about 24 to 48 hours if you go to our YouTube channel, and you can check it out there. Once it's uploaded, you can watch it, and we will. You can also check out the other webinars that we have archived there as well. If you are interested in professional development hours for watching this webinar live, you'll get an email sometime tomorrow with an evaluation link, and you can get your PD credit for attending the live recording at that point. And lastly, if you have any questions or want to interact with Sarah throughout the presentation today, please use the chat feature in Zoom. And don't forget to change the to so that it's sending it to everybody, not just the panelists. That way everybody gets to see what questions you have, see your great comments, and we can all learn from each other from that. So without further ado, I'm going to go ahead and turn it over to Sarah so she can take it away.
Great, thank you. All right, let me go ahead and get my screen share going. All right, success?
You got it.
Perfect. All right. Well, welcome everyone. As Brian said, my name is Sarah Phelps, and I am an instructional technology coach for the LTC. I'm also a CSfundamentals facilitator, or Code.org CSfundamentals facilitator. I've been in my current role now for about 4 months. So before I became a instructional technology coach, I was an elementary computer science teacher for 5 years. And prior to that, I was a 4th grade teacher. So today, a lot of the things I'm going to share with you are things that I have personally used. And so, like Brian said, if you have any questions related to how I use this in my classroom, because I used many of these resources even before becoming the computer science teacher, I just use them in my general ed class. We can definitely talk about those procedures and how I did it. I love talking about this topic, so I would be more than happy to answer any questions that you have. And that goes for you watching the recordings as well. As you can see, my email is here. I am happy to talk through any questions that you have regarding computer science education in the classroom. So today, we're really going to talk a lot about Code.org CSfundamentals, just because it's a great resource and it's free. And I know that school districts are oftentimes looking for resources that are going to not only be quality, but be affordable. So that's going to be the primary focus today, but I'm also going to share other resources that I've used and other things that have been successful in integrating computer science into the classroom. So I just wanted to start off with a little bit of a maybe a rationale or a reason. What's our why? In CSfundamentals, computer science is using the computer or the power of computers to solve problems. And that is so critical. I know I've had parents, I've had administrators, I've had teachers question like, why computer science? We've got so many things on our plate, so many things to teach. Why computer science? Well, it's actually even more than just harnessing the computer power of computers to solve problems. When we think about computer science, we're actually talking about one component of kind of computing in general. So computer science, what we call computational thinking and coding all kind of overlap a little bit. And what we are trying to help our students develop is skills that are going to make them successful in the 21st century. And it's more than just computational devices like computers and technology that they interact with. Computational thinking is a huge subset of thinking skills that allow students to tackle big problems, to look for patterns, to abstract, and then come up with a plan, a critical plan to solve problems. Coding really is a really small part of computer science, and it's just learning how to talk to the computers to get them to do the things that we want them to do. So computer science really supports this student learning even more than just on the physical device. Those computational thinking skills, as I mentioned, are so incredibly important to our students, whether they pursue computer science as a future career or some kind of computing. These are skills that are going to make them just amazing problem solvers and critical thinkers. The core components of computational thinking are decomposition, or knowing how to break down a complex problem into smaller problems. Pattern recognition, we're looking for connections to the problems that we have and experiences that we've prior had. Abstraction, which is, kind of looking at information and determining what's important and what's maybe unimportant or irrelevant at this time. And then algorithms. So, designing simple steps to solve problems. Again, these are applicable whether you are looking at computer science or you're looking at just general problem solving, tackling it in math and reading and science and social studies and PE and art and music. And computer science supports this computational thinking and helps our students just really be able to tackle any problem life throws at them. I love showing this picture. Computer science as we know it. This is our first computer. It was developed in 1943. My students love looking at this photo because they just can't even fathom that a device that now fits into the palm of their hand, right? A smartphone used to be a size of a room, used to fill it. And they love when we talk about bugs and how originally they were actual bugs that got into the hardware and caused problems. But just to reaffirm and to reiterate the fact that computer science and computational thinking are more than the actual devices, this is the first computer programmer. Ada Lovelace worked with Babbage on the Babbage computational machine in 1843. So these skills and this way of thinking really truly supports students and in a well-rounded manner. So bringing in coding and bringing in computer science into your classroom is just going to help your students tackle bigger, awesome problems. It really supports those 4 C's. They're going to be communicating, they're going to be working together and collaborating, they're going to be critically thinking, and they're going to be using creativity. So this is such a great tool as a teacher, whether you teach computer science or you teach a general ed class or you have a content class. Computer science can still be very much beneficial to your content, but also it's just going to help your students grow more. Plus, we know that our students are going to be using technology. Technology is in everything that touches definitely their lives, but also ours. As teachers, right, we have the responsibility of preparing our students for the future. And we always know that we're really preparing them for a future that we don't even actually have a full grasp on what it's going to look like. And so we want to make sure that the skills that we're providing them, well, number one, are kind of universally applicable, right? They're going to be skills that they can apply to any path that they go on. But we definitely know that technology is going to be a part of their path because it's a part of our lives in every way, whether it's the device that we use, our communication, right, with our loved ones, with our bosses, with our clients, with our families. It's our control of our thermostat at home. You have a Nest or you have a smart thermostat. It might be in healthcare. So we know that there are some surgeries that are performed by robots. There are health metrics that can be taken by technology. That little sorry, I just lost my word. Contact lens in the corner can take biometrics. We have our GPS systems, and even our entertainment is developed and created by technology. Our students are going to be using technology because they already are. We know it impacts every component of our life. Online banking, travel, everything is controlled through technology. And so by giving our students access not only to using technology, which we know many of them do, but actually creating with technology, being not just consumers, but producers, is going to set them up to be quite successful in the future. Technology affects every field. This is not even an exhaustive picture, right? We know that it impacts things from agriculture to weather to travel to space to everything. So we want to just really show our students the power that technology has through computer science. Computers and software are changing everything. So what our goal is that every 21st century student has a chance to learn about algorithms, how to make applications, and understands how the internet works, right? Because we know that they learn about other systems like photosynthesis, their digestive system, electricity. Again, we don't teach those expecting them to be experts in those, like to only go into those fields. We don't expect them all to be electricians or to be electrical engineers or botanists or doctors or GI doctors. We know that these are all things that we have and interact with. So we want them to have an underlying kind of understanding, and then they can pursue it further if that's of an interest to them. Recently, a new report came out to kind of show Illinois and where we're at. We know that as of December 1st, Illinois has officially adopted computer science standards. This graphic tells a lot of things. Right now, Illinois averages about 22,000 computing jobs each month. So those are open jobs. They average a salary of $84,000, yet we only actually graduate 2,500 students in computer science. That's for the whole year. So we know that there are jobs to fill, and we want our students to have the skills to be able to fill those jobs. Even more telling, and why I'm incredibly passionate about computer science at the elementary and middle school level, is that kind of teal box there. Currently, 80% of Illinois high school students are attending a school that offers an introduction to computer science. So that was one of the stipulations in the House bill as well, that every high school is going to offer a foundational computer science class. But only 4.1% of students right now are taking that class. And this, I believe, is because students who go into high school and are picking their course load are very unlikely to pick computer science as a course if they've never experienced computer science prior to entering high school. It's kind of intimidating. And this is usually where I share the story about my first experience with coding. My husband is a software engineer. And so that's his job. He programs for a living. And he would always tell me that I should try coding. Just try it. Everybody should try coding. It's fun. And I always felt very intimidated by that. I was very scared to even acknowledge that I wanted to try, because in my mind, I had no background. It was kind of like trying to speak a foreign language without ever taking any courses in it. And growing up in rural Illinois, that wasn't an option for me. I didn't have access to it. So it certainly wasn't something that I was going to pursue post-secondary. Giving students access to computer science education and making it a known as early as kindergarten, which I'm going to share resources today with you that you can do that, is going to make it so that when students walk into the high school for the first time, they can very confidently know exactly what computer science is, know how amazing and fun it is, but also know how powerful of a tool software development is. And coding and computer science can be such a great way to express themselves or to come up with a solution to a problem that they have. But again, they don't know that now because they're not being exposed to it. I also believe access earlier is going to solve some of those disequity problems that we have. We still have lower numbers of minorities and girls entering computer science related coursework because, again, they have had a long time of no access. And so jumping into those courses seems unreasonable or unrealistic. So providing opportunities for computer science earlier, I just know that we are going to have more and more students who are actually taking advantage of those courses in high school. And then of course, later at universities. So solving this diversity problem that we see in the computer science workforce starts, I believe, right now in elementary school, in our junior highs. We want to get more students access so that they can then say, yes, computer science is for everyone. So our big goal today is to talk about the CS Fundamentals curriculum. Again, because I believe that it's just a fantastic resource and it's free. Again, I'll share other resources, but CS Fundamentals is kind of near and dear to my heart. It happens to be the first curriculum that I used when I began teaching computer science. I was very excited and I asked my school district, hey, okay, great, I'm in. What am I? I was always really passionate about STEM and I did a lot of science experiments, hands-on exploration in my classroom. And so, becoming the computer science teacher at the elementary level, I thought that seems reasonable. I can do this. And I asked my school district what resource they thought that I should use. And they said, we have no idea. We thought that you would be able to figure that out. So I very quickly Googled computer science, elementary computer science curriculum free. And the very first thing that came up was code.org. And not only is it free, but they provide training, which, side note, we'll talk a little bit more about an upcoming LTC training. Today's kind of just your taste of the CS fundamental curriculum, but we are offering a full day training in February that I'm going to share sign up information with you at the end of this presentation. So CS Fundamentals is meant for elementary school students. It is kind of written with kindergarten through fifth graders in mind, and it's broken up into courses A through F. You can kind of see the alignment here. Now, when I say it's aligned, what I'm kind of saying is that it's written with grade level appropriate literacy and math skills in mind. So your course A is going to kind of align with what we expect kindergartners to be able to do. Course F is going to kind of align with what we expect fifth graders to know. It is constantly being rewritten to incorporate teacher feedback. So every year there's a new version released with updates and enhancements and improvements. This is wonderful. This next key thing is it's a mixture of plugged and unplugged, which means offline activities play a major role in CS fundamentals as well, mostly because we know that we have lots of different styles of learners in our classroom who are going to access information differently. And we also want to make sure that we are providing an equitable approach to these computer science concepts, because not all of our students spend a ton of time on electronics, as crazy as that sounds. We don't want to discredit that some students just may not feel as confident on a device. But again, as mentioned, these concepts go way beyond just what they can do on a computer. So helping them recognize these computational practices and thinking can happen offline and online. And as students get older, the course levels increase in length, but also in their complexity. And actually in the upper courses E and F for fourth and fifth grade, there's a lot more open-ended project-based learning, which is really great because it kind of helps students transfer from kind of understanding and practicing with a tool to actually implementing it and using it in a way that they see it fits and what they want to accomplish with it, which I think is really great. So let's talk kind of an overview of what's involved in courses A and B. And I want to make sure that you recognize, because I haven't said this yet, but hopefully hinted at it when I was talking about my experience with computer science education. You don't have to know anything about computer science to incorporate computer science CS fundamentals into your classroom. It is very much supported. Not only does it support students with videos and activities that build in their complexity, but you as a teacher will have access to all kinds of very robust lesson plans that help you understand any key words or vocabulary, help you understand concepts. There are videos that you as the teacher can watch so that you understand concepts to support your students. It's really intended to be implemented by anyone, no coding background required. So in kindergarten and first grade, which would be courses A and B, they definitely take advantage of storybooks. So we know that students love those read alouds and they help introduce those concepts of computer science like sequencing and programs and loops and events. They also have a really simplistic user interface, so students can use them even though they're probably in that pre-reading stage. So you're going to notice a lot more symbols instead of words and very simplistic directions in courses A and B. And the goals of this course are really simple. We want to build competent thinkers. That's where that computational thinking comes in. We want our students to start to, decompose problems and look for algorithms that will help them create a solution to the problem. We're building that problem solving capacity, but we're also building a healthy failure and what to do when something doesn't work the way that you expect it to. So we're building that tenacity, and that it's kind of getting rid of a fear of a failure and frustration. They're going to learn the tools. They're going to learn how to move blocks, get rid of blocks, click blocks together. And hopefully we're going to start to really get them excited and interested in computer science. Courses C and D, so second, third grade, these are really very similar to what A and B offer, but now we know that we have some readers. So you're going to see less simplistic blocks. You're going to see more text. You're also going to see kind of more expanded activities. So meaning after a lesson, students are going to have access to end of stage extras. They're also going to start to get some higher level thinking puzzles related to prediction. So kind of looking at code and saying, based on what I know about those blocks, here's what I think is going to happen. They're going to cover very similar concepts, especially in C, loops, events, sequence programming. Once you get to course D, you're going to see some more sophisticated computer science coding with nesting statements and conditionals. But again, our goals are still pretty similar. We're going to enhance that problem solving. We're going to continue to build that resilience so that we don't get frustrated when things don't work. We're going to master those basic skills. Courses C and D are the perfect introduction levels for any level. I often tell teachers, if you're getting started and you have students who've never programmed ever in their life, courses C and D are kind of my favorite entry points for students, because it builds that competency, it builds that confidence, and it helps them master the basic skills and love computer science. Courses E and F are going to bring in some more, not only kind of higher level concepts like functions, variables, for loops, and parameters, but it's also going to give students an opportunity to create projects. So a lot of courses A through D are puzzles. So students are solving problems. They have to break down those problems, but there's still kind of a right, quote unquote, right answer, or there's at least an end goal in mind. In courses E and F, there are open-ended projects where students actually get to identify something that they would like to create and work on creating it. So they're much more application, and students can really begin to see coding as the tool that it is, which is, getting the computer to do something, solve a problem, or provide a value that we don't already necessarily have. They get to experience autonomy, and they get to decide how they want to employ those coding resources. It's going to start to combine skills. So students are going to start to layer on all of the things that they've learned to be successful. They're going to feel empowered and obviously love computer science. Again, as mentioned, these every single course A through F is going to harness both unplugged activities, so teaching students about these computer science concepts without a device, as well as plugged activities. So you can see here that concept of kind of the puzzles I was mentioning. This is from course D. You see that they have to figure out how to get the pig or the angry bird to the pig using those blocks. This is a plugged activity. And we bridge those together so that students understand the concept and then can apply it in their coding puzzles. Here's a great example to kind of help you compare what pre-readers look like versus the readers curriculum. You can see that that pre-reader is very simplistic. You can't see the full directions, but they are very kind of straightforward to the point. The blocks are very simple. They have that giant arrow to show which direction the bird's going to move. It's just much simpler. The actual courses C and on, that readers is going to have move forward, turn left and right. It's going to be just a little more complex. In both cases, there are accessibility features built in. Students can hear, they can push play and hear the directions, which is really great. Code.org also has just a huge number of languages that it's been translated into. So this is a resource that is fantastic for all your learners, whether it is your special needs students, your IEP students, or your ELL students. Those are already in place. There are resources already in place to help you use this with any student. And again, they have an entire curriculum. It's not just puzzles online. You as the teacher have access to all very robust library of activities. The online and offline activities have lesson plans that walk you through step by step how to use the lesson in your classroom. There are reproducibles. So for a lot of the offline ones, you might need an activity sheet or something that you might, manipulate with the students. It's all there for you. Again, there's a video that you can watch if you want to see the lesson in action. In the plugged or online activities, there are always videos that introduce concepts for students to watch. They love it because a lot of times it is, famous people that they know, like Bill Gates or Mark Zuckerberg, explaining a concept. So they're very engaging. Their favorite is Chris Bosh, the basketball player. But those videos help the students relate the concept to the activity that they're doing. And it's all there ready to roll. As a teacher who had no computer science background, I felt very confident that I could tackle this curriculum because I had everything that I needed, but really also feel empowered that you don't have to have all the answers, that the whole process and the part of the journey with computer science education is how helping your students kind of embrace this, failure is part of the process, and teach them how to really decompose problems. That was one of the things that we spent a lot of time. My students would have a puzzle pop up and they kind of start to panic because they didn't immediately know how to solve it. And so we spent a lot of time talking about different problem solving strategies. How can I tackle this problem? How can I decompose it? What do I do first? I had to help them get over this fear that if they hit run and it didn't work, that something bad was going to happen. They were going to lose points, or their score was going to go down. That doesn't exist. Code even got rid of it. Used to, when a student didn't solve the puzzle, it would say like, uh-oh, or oh no, or something to that effect. It's gone because nothing bad happens. It's okay. It didn't work. Let's go back and see what we can change or fix. Your students are so validated, and they just don't get discouraged like they do in other things. So if nothing else, computer science also brings that to your classroom, this opportunity for students just to experience it on their own terms, like success on their own terms, and to learn that life is about continuing to tackle hard problems until you find a solution, not getting discouraged because you've had negative feedback, whether that's in a grade or a rubric or something. It's just about, let's solve problems, because solving problems is fun. So again, that was like everything and all the things that you need to know about computer science in 30 minutes or less. I would love to talk to you more about it. So I would love for you to come and join me at a full day virtual workshop. During that workshop, we're really going to get into the resources of code.org. I'm going to show you how to access all those amazing lesson plans. I'm going to show you how to set up a class and how to track it. Your students' progress. I'm going to talk to you about implementation in a classroom or in a specialty class. So I've experienced both. I've used it in my regular classroom. I've also done it as a specialist. I'll talk about kind of those processes that I had in place. It's a full day workshop, 8:30 to 3:30 virtual, and I'd love for you to join me. But I did want to share other resources today. I didn't want to take up your whole time with CS Fundamentals. I just wanted to make sure that you know that this fantastic resource exists. If you're a middle school teacher and you are saying, wow, CS Fundamentals sounds great, but what about my middle school students? There are actually resources for you as well. So we have CS Discoveries, which is the middle school's curriculum, and there's even CS Principles, which is a high school curriculum that code.org offers. Also free. Training is provided. That's a little more intensive training, but the LTC is the regional partner for code.org. So if you are interested, or if you want to know more about code.org's resources, reach out to Brian or myself, and we would be happy to let you know more about that. So on to additional resources besides code.org. So again, my background having the computer science elementary course, I used code.org as kind of my core curriculum, but there are a lot of resources that I pulled in to supplement or to kind of reinforce concepts that we were doing. Computational thinking, all of these resources are links, and I'm being presumptuous, but Brian or Matt, will you chime in? This is a slide deck that can be shared with participants. Is that true? Because these are all
Absolutely.
awesome.
Yep.
These are all hot linked for you. I'm not going to take time to click through them all, but I'll kind of give you a rundown. But these are all things. Again, I tried to focus on free because again, I know districts have constraints, and I wanted to get you as much amazing resource that was not going to cost anything that I could. So these resources are all computational thinking resources. So these are all, or I shouldn't say all, but primarily these are things that can be done offline. CS Unplugged is completely offline. If you want to teach some of these concepts of computer science, but you'd like to do it in a way that doesn't involve the computer, or CS Unplugged, almost every lesson corresponds to a content area. So you want to start to mix in some of those computational thinking resources into your content. It's a great place to go. Same thing with the others, digital technology hubs, computational thinking lessons. That's the name of the website. ISTE has some great resources for exploring computational thinking. Teaching London Computing, and even code.org has a computational thinking lesson. All of these resources are going to help your students develop those 4 components that I was mentioning at the beginning of this, that, algorithms, dissecting the problem or decomposing the problem, abstraction, so deciding what information is important and what we can kind of put aside, and then and my brain is drawing a blank, but the other one. All of these are going to help your students be problem solvers. They're going to help them tackle hard problems. Again, as we know, that's a skill that whether they go into computer science or not, that's going to make them successful. People that are kind of those people that tackle the big difficult problems are the people that make a difference in the world. And computing is one way that they might be able to do that. But developing these skills are going to help those students be successful no matter what. So these resources are great and can easily tie into what you're doing already in your classroom. If you go on, you can even filter in most cases by what content area you're looking for, just to kind of show that. We'll see. I know AWS could sync me here, but nope, it's good. Okay, so here we are on that CS Unplugged. And again, a lot of these resources are very similar. If you go to curriculum integrations, you can see right here, writing, art, math, numeracy. So you can find some really great ways to incorporate computer science into what you're already doing in your class, and do it without using a computer, which is kind of cool. All right, so moving on. So again, computer science on the computer, code.org is a great resource. Here are some other coding and computer science apps or websites that I've used for a variety of things. Like I mentioned, code.org is very kind of puzzle driven. And so students are learning kind of the big concepts in coding. A lot of the free resources that I have listed here are going to be more of that open-ended experience where students can start to use their computer science background and knowledge to create. So Scratch, for example, is kind of a sandbox. Students can actually build code to do whatever they want, tell a story, they can build a game, they can have an interactive presentation, all kinds of amazing things. There is some guidance there. Scratch has built-in tutorials. Google CS First, which is also listed a couple down, also leverages the Scratch platform, but it has a little more lesson-based activities. Make Code is from Microsoft. Also totally open-ended sandbox environment. These are where your students can go to create. I like using these in conjunction with code.org because those top 3 there are where students have that autonomy to build and design whatever their brains are coming up with. And there are lots of great resources out there to support those. YouTube has lots of tutorials and I love them because a lot of them are made by kids. Blockly Games is kind of another simplistic way to learn about computer science and how the block code works. Code for Life is another free resource that has lessons built on that kind of maze-like platform where students are trying to get from point A to point B. So it's really reinforcing algorithms. And then Code Academy and Code HS are going to be for your older, more advanced programmers, but all of those things are free. They are great. They're supporting of the students and the teachers, and they're wonderful resources. Subscription-based, this is not even the tip of the iceberg for what exists out there, but these are some that I have experience with. CodeMonkey is actually language-based, so it's a simplistic coding language, and I've used that with my students who were like, "Hey, Mrs. Phelps, I love coding, but I know that, I know that it's actually text, all of the resources that we're using on code.org and Scratch, those are block-based coding. They wanted to try actual text coding. So we've used CodeMonkey as well as Code Combat. And Tinker has some resources. Tinker has some free, some subscription. And CodeSpark, these are all things that have some free components, but have some paid components. They're great for your students who are interested or motivated to work even further than what they're working on in your classroom. These are things that I know that students have also used at like coding camps and after school programs as well. So these are all some great resources and all pretty highly rated on Common Sense Media as well. That's kind of where I went to dig through what was out there as well. But there are lots of applications for iOS and Android as well that are actually coding apps. But again, most of those have kind of a cost associated. So here are some free options. Here are a couple of subscription based that I have used and can kind of attest to. And then the other thing that is definitely a cost, but that I did use when I was teaching computer science, and that's robots. So for some of my students, doing coding on the computer was amazing. It was fun. They loved what they could accomplish. It was very much the tool that they needed to get excited and learn about programming, but not every student felt that way. And so for some of them, that physical computing was actually kind of my hook. So, and I oftentimes have districts that want to talk about robots because again, that cross-curricular link, robots can allow for you to incorporate robots or computer science into coursework that teachers are already doing. And I do that as well. I did that when I was in the computer science role, but I do that as an instructional coach too. Bbot and CodeMouse and Botley are all very simplistic robots and actually not awful expensive. CodeMouse and Botley are both from Learning Resources. Bbot is its own. But they have a very simplistic user interface. You're using arrows to tell the robot what directions you would like it to go. And they tie into any sort of a map that you want to create. So whether you want the robot to go to a specific word or a specific letter or a specific place, you can really tie in a lot of curriculum into those robots. Ozobot is a very, very versatile robot because it can basically be used just as that like engagement mechanism where students are, using lines to get to places. Ozobot is color coding. So you have students are problem solving and using that computational thinking to navigate the robot from one point to the other. And it's also one that's very easily integrated. There's a huge, robust library of activities already, but they're also really simple to make yourself once you kind of get the hang of what the Ozobot activities look like. Lego Robotics is more of an investment, but it's another one. Students are very familiar. They're comfortable with Legos, so that's a good access point for some students. That's kind of an easy transition because they feel very confident with the Lego part, and so programming it just comes kind of naturally. And then Sphero, again, not an exhaustive list. There are lots of other robots out there, but I definitely see value in adding robots into your curriculum if that's something that you can do. Maker spaces and things like that were quite popular right before the pandemic. So I know for some schools, these are resources that they have and they're just not sure how to employ. So we could do a whole webinar just on robots in the classroom, but they are definitely worth an investment if it's something that your district is interested in incorporating. And again, I would be happy to talk about those more in depth. I just wanted to give you kind of that overview. Today's all about the quick overview. All right. I think that gets me to the end of my presentation. Brian, Matt, any questions that have popped up or that you have?
Nothing has popped up in the chat. I do believe it looks like Matt has allowed participants to unmute and ask questions if they have so. So we'll go ahead and pause for a couple minutes here to just see. You feel free to type the question in the chat box or unmute yourself and ask any questions.
Ta-da.
Well, I don't see any questions coming through, so we'll leave this up for a second. I do want to make sure that I reiterate, I know you mentioned this during your presentation, Sarah, but if you are interested in attending the CS Fundamentals workshop in February, it is free. We have just a select number of seats available to this one. So please go ahead, and if you're thinking about it, go ahead and register for it. If you have any questions, you can feel free to reach out to me at bbates@ltcillinois.org and ask any questions you might have. But otherwise, feel free also to reach out to Sarah, because as she did today, not only does she work as a facilitator for CS Fundamentals, she's very passionate, very knowledgeable about computer science in general, and would be more than happy to help answer questions or help you out in any way she can. So Sarah, thank you so much for joining us today. Matt, thanks for helping out on the back end, and we will see everyone later. Hopefully you have a wonderful Computer Science Education Week.